Right now, while you're watching this video, Europe and America are drifting apart. Not metaphorically, literally, physically. Every year, the distance between them grows by about 2 to 4 centimeters, a bit faster than your fingernails grow. In 200 million years, the Atlantic could turn into an ocean so massive, it would make the Pacific look like a puddle. The Atlantic Ocean is the only one on Earth that is literally growing right before our eyes. And that's just the first line in the case file I've put together. It only gets stranger from here. An ocean with a sea inside it that has no shores at all. A current that determines whether Europe freezes or not. And a zone sailors are afraid to even talk about out loud. Let's open the file. Hey, today we're building a case on the Atlantic Ocean. It's the second largest on the planet. But when it comes to sheer weirdness, it's the undisputed leader. We'll go through the case, piece by piece. Exhibit A, how it was born, and why it's younger than you'd think. Exhibit B, its unique shape, and a place that physically doesn't exist in any other ocean. Exhibit C, a hurricane factory off the coast of Africa. Exhibit D, an invisible mechanism that literally keeps half of Europe from freezing, and one that could someday stop. Exhibit E, mysteries, vanished ships, the deepest point, and an island that's literally being torn in two. By the end of the video, we'll deliver our verdict on why, out of every ocean on the planet, this one is the most unpredictable. Let's begin. The first piece of evidence concerns age, and right away, there's a surprise. The Pacific Ocean has existed, in one form or another, almost since the Earth's crust first formed. Its age, counting its ancient predecessors, is estimated at hundreds of millions of years. In places, over 1 billion. The Atlantic is a teenager by geological standards. It's only about 140 to 180 million years old. It formed when the single supercontinent, Pangaea, began to split apart. The crack ran exactly where the Atlantic sloshes today. Want to see the scar from that split with your own eyes? You can. It's called the Mid-Atlantic Ridge, an underwater mountain range that runs the entire length of the ocean, north to south, from the Arctic almost to Antarctica. It's the longest mountain system on Earth, over 16,000 kilometers. For comparison, that's longer than the Andes, the Rockies, and the Himalayas combined. And this ridge isn't a monument to the past. It's alive. This is exactly where, along the crack, the continents keep drifting apart. That's why the Atlantic is the only major ocean actively growing in size, while the Pacific, by contrast, is slowly shrinking, its ancient crust sinking back into Earth's mantle at its edges. Conclusion on Exhibit A. This ocean doesn't just exist. It's still in the process of being born, stretched out over tens of millions of years. Exhibit B, shape. Take a look at the map. The Atlantic is the only major ocean with such a distinct S shape, or, if you prefer, a mirrored Z. The eastern coastline of South America looks like it was cut specifically to fit the western coast of Africa, because at one point, it literally was pressed right up against it. But the strangest detail isn't at the edges of the ocean. It's right in the middle. Picture a sea with no shore at all. Not on any side. A sea whose boundaries aren't made of land, but of ocean currents. A place like that only exists in the Atlantic. It's called the Sargasso Sea. It's surrounded by 4 currents, including the famous Gulf Stream, which spiral around it and trap calm, almost motionless water inside that zone. The sea gets its name from sargassum, brown algae that float on the surface in massive drifting islands, sometimes stretching for thousands of kilometers. It was exactly this dead calm and the algae tangling around ship hulls that made Age of Sail sailors genuinely dread the Sargasso Sea. They believed ships could get stuck there forever. Partly legend, partly true. Without wind, a sailing ship really could sit motionless for weeks. Neither the Pacific nor the Indian Ocean has anything like this, a sea with no shore whatsoever. Exhibit C. The Atlantic produces something no other ocean produces at this scale, with this kind of predictable geography: its own hurricane conveyor belt. About 60% of all major Atlantic hurricanes are born at the exact same spot, near the Cabo Verde Islands, off the west coast of Africa. Scientists actually call this type of storm Cape Verde hurricanes. The mechanism works almost like an assembly line. Dry, scorching air from the Sahara Desert collides with humid air over the ocean, creating zones of instability. These zones roll off the African continent into the ocean on a regular basis, like parts coming off a conveyor belt. And as they travel thousands of kilometers over warm water, they grow into some of the most powerful hurricanes, including the infamous ones that later slam into the Caribbean and the US East Coast. Interestingly, the Saharan dust itself, carried into the atmosphere over the ocean by wind, plays a double role. In large quantities, it suppresses hurricane formation by blocking sunlight and drying out the air, while in smaller quantities, it barely interferes at all. The Atlantic is the only ocean whose main hurricane conveyor belt is this tightly linked to processes happening on the land of a neighboring continent. And now, the piece of evidence that's genuinely been keeping climate scientists up at night for the past few years. There's an invisible mechanism that's been running inside the Atlantic for thousands of years. It literally keeps half of Europe from turning into Siberia. Without it, winters in London, Paris, and Oslo would be as brutal as winters in Canada at the same latitude. Several recent studies have shown this mechanism is slowing down, and if it ever stops completely, which, according to some scientists' calculations, could happen as early as this century, Europe would face a cooling of several degrees within just a few decades, not in 1,000 years, within your children's lifetime. Let's dig into this evidence right now. The mechanism I'm talking about is called the Atlantic Meridional Overturning Circulation, or AMOC for short. The Gulf Stream is just its most famous surface-level part. Here's how it works. Warm, salty water moves north from the equator along the ocean's surface. That's the Gulf Stream. When it reaches the North Atlantic, near Greenland and Iceland, the water cools down, becomes denser due to the cold and high salinity, and literally sinks, dropping several kilometers deep. From there, now as a deep, cold current, it slowly makes its way back south, closing a massive loop that churns the entire Atlantic Ocean from top to bottom. This conveyor belt transports a staggering amount of heat, by some estimates, comparable to the output of 1 million large power plants running continuously. That's exactly why Western Europe, sitting at the same latitude as Canada, enjoys a relatively mild climate. Here's the problem. This conveyor belt depends on the salinity of the water at that northern point, the spot where it's supposed to sink. And Greenland's glaciers are melting at record rates right now, dumping enormous volumes of fresh water into the ocean. Fresh water is lighter than salt water. It dilutes the current and makes it harder for the water to sink to depth.
Studies in recent years, including data analysis from 2021 and 2023, have found signs that AMOC is weakening and losing stability, possibly for the first time in over 1,000 years. Some climate models suggest that under certain scenarios, a full shutdown of the circulation is theoretically possible within this century, though scientists stress that pinpointing the exact timing is extremely difficult, and some researchers consider a full shutdown within the coming decades unlikely.
If it does happen, according to climate scientists' calculations, average annual temperatures in some parts of northern Europe could drop by several degrees within just a couple of decades, a rate of change more comparable to a climate catastrophe than to the gradual warming we usually hear about in the news. The paradox is that global warming can trigger a sharp local cooling simply because the wrong ice is melting in the wrong place. Exhibit E, the Mysteries and Records section. Let's start with the most famous one. The Bermuda Triangle, a stretch of the Atlantic between Bermuda, Florida, and Puerto Rico, where, according to legend, ships and planes vanish without a trace. The statistics, however, don't support any anomaly. Insurance companies and maritime agencies don't record a higher rate of disasters in this area compared to other zones with similarly heavy shipping traffic. The mystery is most likely a product of sheer traffic volume and selective media attention to individual cases, rather than anything supernatural. But here's something that isn't a myth: the depth. The deepest point in the Atlantic is located in the Puerto Rico Trench and is called the Milwaukee Deep, nearly 8,400 meters down. That's shallower than the Mariana Trench in the Pacific, but still deep enough to completely submerge Mount Everest, with several hundred meters of water left over on top. And the final exhibit in this section, a place where you can literally stand with one foot in North America and the other in Europe. That's Thingvellir Valley in Iceland, the only place on land where the mid-Atlantic ridge, that same crack we talked about at the beginning, surfaces and is visible to the naked eye. The ground there is literally pulling apart a few centimeters a year, and you can reach out and touch it. The last piece of evidence concerns the future. We've already established that the Atlantic is growing, but will it grow forever? Geologists describe the life cycle of oceans using a model called the Wilson cycle. An ocean is born when a continent splits apart. It grows, reaches a peak, and then, if zones start forming at its edges where oceanic crust sinks back into the mantle, it begins slowly closing until the continents on either side collide once again. There are signs the Atlantic may already be approaching a turning point in its cycle. Near Gibraltar and in the Caribbean basin, geologists are detecting early signs of zones forming where oceanic crust could start sinking back into the mantle. By the boldest estimates, in 200 to 300 million years, the Atlantic could begin slowly shrinking and eventually close entirely, the same way a much older ocean once closed, one that used to separate parts of what is now Eurasia. Funny enough, while one ocean is theoretically gearing up to close in a few 100 million years, a new one is already being born on the other side of the planet. In the East African Rift Valley, the continent is literally cracking apart right now, and in a few million years, a new ocean could appear there, following the exact same script that gave birth to the Atlantic 180 million years ago. So, the case is closed. What did the evidence show? The Atlantic Ocean isn't just the second largest after the Pacific. It's the only major ocean that's still physically growing. The only one with a sea inside it that has no shore at all. The only one whose climate engine directly determines whether Europe freezes or not. We tend to think of oceans as something static, just a big blue patch on the map. But the Atlantic proves otherwise. It's a living, moving system that simultaneously splits continents apart and holds the climate of an entire hemisphere in a fragile balance. And maybe the most striking part is this. This entire process, from birth to a potential closing hundreds of millions of years from now, is happening right now, right under your feet. Too slowly to notice, but too massive to ignore.
If you liked this investigation format, let me know with a like. I'll make more videos in this style. In the comments, tell me which piece of evidence surprised you the most? The growing ocean? The Sargasso Sea? The hurricane factory? Or AMOC? If you enjoy our channel, you can support it by checking the description. You'll find all the details there. And if you want a full case file on the Pacific Ocean or the Mariana Trench, let me know. We'll open a new dossier. See you in the next one.